Okay, so this is another journal entry. For this particular journal entry, we'll be working with MX1 and MX2 Juniper products. We will be configuring routing options a generate route. Basically, what a generate route is when certain criteria are met for a policy, it will generate a route within your device. So for this particular environment, we have MX1 and MX2. So we're just gonna keep it simple. We have a connection in between them, and we will be configuring loopbacks on MX1. So these loopbacks will be reachable from MX2. For simplicity's sake, the first thing we're gonna do is do a simple static route to one of the loopbacks, and then from there we'll match that static route, and then we'll make a generate route. Okay, for another make the lab simple, we're just gonna make the loopbacks just 10.10.10.x/32. Okay, /32. So we'll make probably 4 loopbacks here, and then for the generate route here, we'll generate a route, a summary route or an aggregate route for /28. And that's what our generate route would be. So what is the purpose of a generated route? Basically, a generated route ensures stability and has that extra layer of redundancy for your network. Just in case one of your routes goes down or a network is unreachable, you can have the generate route step in just to keep the traffic flowing. You can also use this as a mechanism to add an aggregate route or summary route. So you can shrink the routing table a little bit smaller just to make it more readable. But that's not the primary purpose. The primary purpose is just to have a backup route when something happens. Okay. Now let's configure our devices. We have MX1 right now. Okay, MX1. I just configured the host name and that's it. So from here, we will first make sure that the two switches can reach each other. So we say edit. So run show interface thirst. So GE0/0/0. Okay, that's the interface I want. Okay, so I'm going to set interface unit 0 family inet address. For the connection between, just to separate it out between the loopbacks, just to make it more readable, we're just going to say 192.168.1.2 because it's between router 1 and router 2. And for the fourth octet, I'll just make it 1 because it's for router number 1 or MX1. And I'm going to say commit here, and we're going to go to MX2. For MX2, we're going to do the same thing. We're going to say set interface GE0/0/0 unit 0 family inet address family 192.168.1.2.2/24 and commit. We're going to go back here. We're just going to do a simple ping just to make sure they can reach each other. I'm going to say rapid, and the ping is successful. So that's basic connectivity between the two. Again, this is a lab. In real world environments, generated routes doesn't have to be this simple. This is just for labbing purposes. Now we're going to make some loopbacks on MX1. So I'm going to say set interface loopback 0 unit 0 family inet address. As I said before, it's going to be 10.10.10.1/32 2 3 and 4. Wait. So let's just check that all the loopbacks are there. Okay. So we have loopback 0, unit 0, and these are the IP addresses that are available. Now, MX2 does not have visibility to any of these loopbacks. If we say run show route, it only knows what is directly connected and what is local. So if you try to do some reachability to the loopbacks, it will not work. So first thing we need to do is we will create a simple static route. So set routing options, static route. So we're just gonna match it directly. So we're gonna 10 10 10 1 slash 32. What is the next hop? So the next hop will be 192.168.12.1, and let's say commit. Now we should have that in our routing table. So we have that in our routing table. So when we do a ping 10.10.10.1, rapid, the ping is successful. So from here, this is what we're gonna match. We are gonna match this in our policy. Okay, we're gonna match that in our policy, or we can just make it a bit broader, since we're gonna inject a generated route of /28. We'll just keep it simple. We /28 as well, and then from that matching in the policy, we will then connect it to a generate route statement. First, we have to create the policy. So let's create the policy. So I'm going to say edit policy options. Okay, policy options, and then it's a policy statement. Yes, policy statement. So then after this, we need a policy name. So I'm going to say match static route. Yeah, match static route. So from here, we then are in the edit policy options policy statement for the particular policy match static route. So what are the terms? The terms or the if-else statements that we will be setting. So we say set term 1. We will want to match it to a static route. So from protocol static. So it doesn't have to be static. In real life, you can have a lot of matching. Sometimes in my work, you can use BGP, match BGP, MPLS, or layer 2 circuit. Sorry, there's some construction going on. Hopefully it's not that bad. You can still hear my voice. So set term 1 from protocol static, and then from that static we want to match a route filter. So we say set term 1 from route filter. Okay, so the filter is going to be 10 10 10.0 /28, and then it's going to be longer than 28 because for our case our loopbacks are /32 or longer. Okay. Then what do you want to do with this? If we just show right now, you can see that we are matching some criteria, but once that criteria is met, what do you want to do? Do we want to accept or do we want to reject? So we will say set term 1, then accept. Finally, we will have set term 2, then reject, just to make it clearer. So if it doesn't match anything, we will just reject it. So our policy is done. So now we have to connect the policy together with a generate route. So I'm going to say top to bring me back up. Set routing options, generate a route. What the route we want to generate? 10.10.10.0/28. What's the policy? Policy is going to be match static route. Okay. So show compare. This is what we've done so far. We've created a policy and we've connected that policy to a generate static route, and that should be it. If we say run show route at current moment, we do not have a route that is /28. So we say commit. Once we commit that, we say show route. Sorry, I say run show route. Now we have a /28. From here, you can successfully ping all your other loopbacks. Done. So let's just look at more details on our generated route. So we can say run show route protocol aggregate. This is considered an aggregate route, and we want to see the details. From here you can see that our generated route took the next hop of 192.168.12.1. If you remember previously, we did not set a next hop for this generate route. In simpler terms, a generate route would take the next hop of the primary contributor of the generate route. It's just the mechanism, the way it does it. So if we look at, this is going to be our primary contributor, and this is the next hop value. If you look at the details, for this particular network, the next hop value is 192.168.12.1, and this is the contributing routes. For example, if there's multiple contributing routes, let's just say we don't have a lot of exit interface or egress interfaces, so it's going to be the same, but you can have multiples. Let's just say set protocol, I'm sorry, not set protocol, set routing options, static route, and let's just say 10.10.10.15, because that's the limit, because it's /28. That's the two. Next hop is, we only have one available egress, so if I make a bogus number here, it will not actually show up. 12.1, because this value has to be valid. This has to be a valid value. 10.10.10. Okay. 192.168. 192.168.12.1. Wow, because I have not committed it. Let's commit, and let's check it again. Now you'll see that we have two contributing routes. When there's two contributing routes, if their value is the same, what I mean by that is when you have two routes that are of the same contributing factor, let's say route preferences or everything else, the primary contributing route would become the lowest route in terms of numerical prefix. So this would be the lowest one, and then this would be the next hop value that will be taken. Okay, hopefully that's a bit clear. Just remember, if everything is equal, it'd be the lowest one. If one of the contributing routes has a lower value or preference, then that one would be picked for your next hop value. Okay. Just to prove another point, if we were to delete these routes, right? If we delete these routes, okay, delete routing options, static route 10.10.10, sorry, 10.1/32 and 15/32, and then we commit. If we say run show route, we won't have any of our static routes that we manually configured, and the generate route will not be there. But if you say run show route hidden, then you will see it is right here, and it's currently hidden and reject because there's nothing matching to it. So if we just say again, set routing options, static route 10.10.10. Let's say 5/32. Next hop 192.168.12.1. Right, and then we say run show route again. Okay, now we have the manually configured static route and also our generated route. So hopefully this has been helpful, and to me in the future, if I'm watching this again, hopefully you still remember this, and if you're somebody else watching this, thank you for watching. That's it.